Wood carver needs to know the material he's working with, the characteristics of the wood, how it's going to react over time. I hope to give you some of the basics of how to select the wood. For selecting the wood, if you had carving you were going to do a Paul Bunyan, you would probably think of oak, him being a lumberjack and a strong fella, and oak is strong, so that would probably be your wood selection for that. But if you were going to carve a refined lady, then you probably wouldn't use oak because of the coarseness of the grain. You'd want a nice, fine, delicate grain, so maybe something like a basswood that would have not much grain at all, or another similar fine grain wood like mahogany or something like that. We're going to talk also about what happens to wood over time. The wood that wood carvers use is normally a solid block that takes quite a while to dry. We'll talk about how to dry the wood, how long it takes. So it's either a solid block like this, or it's a laminated block like this here that's sandwiched together with different pieces. But in any case, first of all, this here, if it's laminated properly, the stresses of the grain are alternating. This is not as difficult to work with, a laminated piece, as it is a solid piece. So what we're going to be talking mostly about is working with a solid, call it dimension stock. So cabinet makers, most woodworkers work with 1-inch pieces of wood, 3/4 inch thickness typically, and they don't run into the problems that a carver does with thick pieces of wood like this, and what's going to happen to the thick pieces of wood. That's what we're going to talk about here right now. What happens to a thick piece of wood? If you think of wood, well, first of all, our reference that we're using for most of this is Fine Woodworking, and it is a magazine, Wood and How to Dry It, and it's by Fine Woodworking. We're going to have a table in there that we're using with the expansion and contraction of the wood because of the moisture, and that is a table that's taken right out of this here book, and it's Tom Liebel. He's a furniture maker and a boat builder in Madison, Wisconsin. He has granted me permission that I can use this. I find his numbers for the expansion and contraction of wood are to be about the best that I can find any place. So we talked about the wood expanding and contracting, and that's what it does. If you picture wood as a bundle of straws that you put together, and those straws, they fill with moisture, and then when they give up moisture, they shrink. A piece of wood is expanding and contracting as the humidity changes. Naturally, in the wintertime, we're talking all in the Midwest here, because that's what I'm familiar with, and our humidity outside drops down below, a little bit below 50% when it gets really cold in the winter, and in the summer it's into the 90%. 95% humidity is very high humidity. So that's the kind of range that we have here in the Midwest. Now, if you seal a piece of wood, so you put varnish on the piece of wood or shellac or something like this, then you would think, well, the moisture is not going to change in there, but it still does. Because it's not a true hermetic seal, some moisture escapes and it absorbs some moisture in the summertime. So that's why your cabinet doors, woodwork, things in the home, in the summertime a door might stick on your cabinet or regular door, and then in the wintertime it works really fine. And that's because it's actually gotten smaller in the wintertime. When it gives up that moisture, it shrinks. So if you think of wood kind of like a sponge, you get that sponge really wet, and that's when the tree is growing. It's very wet, and the sap is going up through the tree, and you cut the tree down, And the first moisture it's going to lose, it's the free moisture. So it's like taking the sponge and you squeeze all the moisture out of it that you can until it doesn't drip anymore, and you let that sponge go and it expands back up. But now it's quite a bit lighter because it doesn't have the free moisture. But the sponge is still basically the same size. But now you let that sponge dry out and it starts shriveling up and it's getting smaller and smaller. And that's when it's releasing its bound moisture. It's the moisture that's left in there. If you squeeze all the free moisture out of there, and then you can still feel that there is some moisture, it still feels wet. So that's the bound moisture. Wood has got free moisture that it loses right away, and then the bound moisture. And so we're going to talk about the drying of the wood, the expanding, contracting. Now a piece of wood, this piece of wood is going to expand out each way, this way and the thickness way, both ways, but it's not going to change in length. The fibers do not get longer with moisture. They're just like a bundle of straws. They will get wider, and so they'll grow in this direction, but not in the length. So this is what the end of a log kind of looks like. You have the heart in the center, and their growth rings. Every year it gets another ring as it gets larger in size. So typically when you see cracks in a log, the cracks go in to the heart. They always point towards the heart. They don't go across this direction. Everything pointing towards the heart. And the reason for that is as the moisture starts escaping from the log, it's going to take the closest path going out. The outside of the log is drying first, and it is getting smaller. It's shrinking. But the heart of the log, there's a longer distance for the moisture to travel, so it's still large. And there's no place, as that ring keeps compressing around that heart, that's where your cracks begin. And that's why the cracks point towards the heart. In this next slide, we talk about the two different kinds of cuts. There's more than that, but the typical cuts that you get, the boards coming out of the end of a log, is you get your plane sawn, which is the tangent. So a plane sawn log is taken out of this portion of the wood right here. So the grain is going in this direction. The quarter sawn, which is this one, is coming out of this section of the wood. And that's why the grain is perpendicular like this. There's another one that's called rift sawn, and that's taken out about here, and that's where the grain's at about a 45-degree angle. It's kind of a combination of the two. But we're not going to talk about rift sawn. We're going to talk about the quarter sawn. We're going to talk about the plane sawn, which is that one. And you can see by looking at the log that you're going to get a lot more yield out of the log by cutting plane sawn rather than quarter sawn, because the quarter sawn, by making these kind of cuts like this here, you're going to end up with less yield than if you cut it just plain sawn all the way across. So the quarter sawn is more expensive wood. It is a better wood to work with, the quarter sawn. If you look at the different cuts, with the plane sawn, the grain going like this, you're going to end up with a flat grain that looks something like this. The grain is going to be wide apart. Looks almost like a plywood. Where if you're looking at a quarter sawn, then you will see the grain being fine. The grain is at a 40 or at a 90-degree angle here, perpendicular to the surface, and it's nice fine grain. So this is what woodworkers prefer for the looks and also for the expansion and contraction. Now with wood, every time the moisture comes in and out of the wood, it changes in size. So here in the Midwest, we're talking about a moisture change of 13%. 13% moisture change is the moisture content of the piece, not the air around it. So if you had a plain sawn piece of wood that was 12 inches wide, it would change over 1/4 of an inch. It changes almost 5/16 of an inch, 0.31 inch. That's what it will grow in excess of 12 inches. So let's hypothetically say that this piece was sawn in the wintertime. The moisture content was very low. In the summertime, this piece would no longer measure 12 inches. It'd be 12 inches, 12 5/8 inches is what it would be. Now, the quarter sawn piece would be about half of that growth. So the same conditions, a 12-inch wide piece. If it's cut real dry in the summertime, real dry in the wintertime, in the summertime it will grow over 1/8 of an inch, 150 thousandths. So the quarter sawn, just as a rule of thumb, changes about half as much as what the plain sawn. The reverse is true. If you were to saw this in the summertime, with the wood typically at being its largest, then in the wintertime it would also shrink. Now all the bets are off when you have kiln dried. It's down to about 5% moisture. It's all going to come back up. Here in the Midwest it comes up to about 13% moisture. And then it will change about a plus or minus 7% moisture. So for a total of 13% moisture change in the wood. And that's with the wood having seal coat on it, like your cabinets. It changes more without the seal coat. Now for that 13% moisture change, this is the different wood. So the different species of wood change at a different rate. So in all cases we're talking a 12-inch wide board, just like in the previous slide. And if you had a basswood board that was 12 inches wide, its tangential change, this is the plain sawn column, and this is the quarter sawn column. It would change 0.28 over 1/4 of an inch per foot, where if it was a quarter sawn, it'd be less than 2/10 of an inch, 0.19. Black walnut changes 0.23, and its quarter sawn changes 0.16 of an inch. We're talking all inches in here. The white oak changes quite a bit. That's almost 5/16 of an inch, and then it's over 1/8 of an inch here in the quarter sawn. So the butternut changed probably the least of the. I like to use butternut when I'm doing church carvings because it matches in with the oak very well and it's much more stable. So that's the reason why I like butternut, and it carves excellent. So it changes a little under 2/10 of an inch per foot, and it's about 1/10 of an inch for a quarter sawn. Hickory is the worst. Let's look at that for hickory. If you notice, the harder the wood, the more the change seems to be. And the hardest on here is the hickory, the next being the oak. As it goes down, probably butternut and basswood are about the same hardness, but there is quite a bit of difference in the change here, almost another 1/10 of an inch. In a laminated board, we alternate the grain so as to stabilize it. So now all the stresses theoretically are stabilized. Now, it's important to note, even though you're equalizing the stress, it's still going to expand and contract in both of these directions. Never changes length, but it'll always, even when it's laminated, all the stresses are equalized. What it does when you laminate it, when the stresses are equalized, it will not warp. It will remain straight. Here's some of the things what causes stress. This board like this can be sitting for 100 years and it's all stabilized stress. It's not warped, it's a flat board and everything. And then you put that thing on a table saw and you start cutting it and it'll open up, or it might close up and pinch the blade. So what it is the stress is stabilized around this knot, so it's equal on both sides, so it won't change. Now you cut this here, and now the stresses are being relaxed on both sides. And that's what causes you, when you're ripping a board, it will sometimes open up on the table saw and sometimes it will pinch. So those are the stresses that you're relieving out of it. What happens with a miter joint? With a miter joint, remember the wood's always changing in size, all right? So if you're going to make a miter joint, let's assume this is going to be the spot that isn't going to move, because it can't go this way because it's pushing against one another. So it has to grow in this direction and it has to grow in that direction. So if you cut a miter joint, leave it lay there in your shop, and you come back a few days later and it's no longer a 45-degree angle, it opens up. So what happens is the moisture comes in, and this point here grows to here. Remember, it doesn't get longer, it just goes from this point to this point, and this board goes from this point to this point. And so now I'm exaggerating it, but that's what happens. It ends up being a bird's mouth. You see, so you normally go and you buy wood and it's kiln dried to about 5%, and you cut your miter joints, and then you have it sitting in your shop. Now that piece isn't sealed, so it absorbs moisture faster and it will start to grow. And it grows from this point, it'll grow up to that point. You see, so that's why you should let your wood stabilize in your shop before you start cutting your miter joints. And then when you start cutting your miter joints, assemble the piece right away using your biscuits and everything. That helps a little bit, but really nothing is going to stop this. So you should have it stabilized in your shop first. The other thing is, if you're making a big picture frame, okay, so what you do is, instead of using a big piece of wood, you use smaller pieces of wood and you frame a frame. Okay, so you keep building smaller frames out, and you let each one being able, so it's not really tight around one another, so each one can expand and contract on their own. That way you divide it up and it's not as noticeable. What happens with dimension stock? Dimension stock, remember we were saying that quarter sawn, which is the bottom here, because the grain is almost at a 90-degree angle with the surface. So this is quarter sawn on the bottom, and this is plane sawn on the top. And I said that it's going to grow at twice the rate. So let's assume this thing is setting on a bracket. This is a fireplace mantle, for instance, or it could be your statue. But let's say this is setting down on a mantle, so it's going to grow in this direction. So we said that quarter sawn is going to grow. Let's pick the dots where it's going to grow to. And then the plane sawn is going to grow more, but it's going to be like, it's going to grow in this direction and in this direction. So someplace up over here is where we're going to be with that dot, and over here. And this distance away here is about half the distance. This is about half of what this is. So let's do a dotted line. What's going to happen to this piece of wood? See, the sides are no longer perpendicular. They're fanning out, but now the top is going to warp. So the top is bowing up, and when the top bows up, the bottom is going to cup also. So it's going to cup in. So you're going to be concave surface here, a convex surface here, and your sides then are going to be tapered out. And this is going to happen every year. So when I talk to a customer about a mantle, a solid mantle, I'll tell them to expect this here, and it's not going to be really flat on the top. So some part of the year it's going to be, and other parts of the year it's not going to be. They expect that, where if it's a laminated piece, like we showed this slide of this lamination here, it then will not, it will grow, but it won't bow. When I was showing that slide, it won't bow. It grows equally in all directions. The laminated one normally costs more because of the labor in laminating. So when you're making a door, you have your stiles on the side and you have your rails at the top. If you examine the construction of that door, and you go and you look at the top of the door, first of all, your stiles are normally 6 inches wide for a normal entryway door or a door in your house. And so the only thing that's going to change, remember this doesn't change here for length. So that door is going to change in size based on this piece and this piece back here. This, if you look at these are almost always quarter sawn. So it's half of the expansion rate. If you use plain sawn for these, then it would be double the growth. So they used a minimum amount of growth, so they used the quarter sawn pieces here, and this is normally 6 inches, and this is normally 6 inches. So you got a total of 1 foot change, and if that is an oak door, you're talking about 150 thousandths that door is going to grow, because it's just 6 inches and that's 6 inches. If we go back to that other table that we had for oak, and we look at that, we have white oak coming across, it's quarter sawn, and we're talking about 1 foot. So we have 150 thousandths. So let's say you put a hinge on this side, and this side is going to change. It's going to move in and out by 150 thousandths, so you have to allow for that when you're mounting the door. You don't want it to stick in the summertime when the humidity is high. In the construction of this door, you have a floating panel that's into a groove, and that a panel is expanding and contracting the same way because the grains go in this direction, so it's expanding and contracting, and it is allowed to slide in and out of these grooves in here without causing the door to get larger or smaller. So that's how a door is constructed. Now if you're relief carving, you have to consider what side you're going to carve from. Now normally if you're a woodworker, this is your decorative side here. This is the pretty side, away from the heart. This is the heart right here, the heart side. The heart is in the log over here. Now, a wood carver carves from the other side. You get the least amount of warpage that way. So remember that piece of wood that we sawn and the stresses were being relieved and it opened or pinched the blade on the when you were ripping the board? Well, this is also relieving stresses when you're carving in the board. So you want to carve from the heart side of the board, and you carve, and the rule of thumb is you don't go any more than halfway through that board. Now when we talk about reaction wood is not good for any type of woodworking at all. It is when the heart of the log is off center, and almost every branch of a tree you will have the heart off center. The grain is very compressed on this side, the growth ring, and they're very wide on the other side. Because you got the same number of rings and the shorter distance here, they have to be compressed and they have to be stretched here. And that's what makes it unstable. We call that reaction wood. There's uneven stress in there and it's unpredictable. You don't know what kind of expansion and contraction it's going to have. It tends to fuzz up more when you're trying to finish it. It does not take a finish well. It doesn't carve well either.